Yeah, I was sitting next to Wow, it's very important.
Yeah, I'm aware, okay. Yeah. What are you thinking? I know my backpack's heavy. You just need to slide it on the floor. Yeah.
Oh, really?
You just need to slide it.
Okay, but
Yeah, but he's supposed to Sophia can help you out.
It's a little classroom.
Okay, I double placed it.
Yeah, double.
I did. Go feel it.
No, it's not me.
That's what you mean.
Yeah, you say that.
That's your mistake.
So,
Fragile.
write down balancing. Write down balancing. In order to be balanced, what has to be true about this ruler?
it's gotta be even on both
It's
sides.
got even on both sides. I have as much on one side as I do on the other.
Why is it red?
I don't know, it's a weird, like, alright, so, to be balanced, you need to have as much weight. That's why his arm is, like, extended this way, so his weight is balanced over where that, like, center of gravity is, of how he is, like, holding himself up there.
Should we say balancing equations is not a
No,
science?
all you need is balancing equations. Okay? Balancing equations. Here we go. So, nitrogen gas and oxygen gas make dinitrogen tetraoxide gas. You don't have to write down those words. Try to write down an equation for what that would be. Talk to the person next to you if need be. Go.
Balancing what?
Nitrogen gas and oxygen gas make dinitrogen tetraoxide. You just have to write down balancing. That's all. The title of today's notes is balance.
Wait, that
So
doesn't.
we're writing that down?
Balance. You write it down. You don't have to write down the words. Write down the equation that words represent.
Yeah.
2 plus O2
Times dinitrogen.
4O.
Those people actually go.
Oh no, you spread it.
2.
2 irons.
Who else is hiccuping now?
Wait, do you what were the gas?
The tetra
Just for the G or what?
Two opponents.
Yeah.
What am I gonna write for nitrogen gas?
N2.
N2, and with the stuff we also learned yesterday, I'm gonna have a little subscript
Oh, yeah,
G.
G.
That's not gonna be super important for what we're doing today, but we can recognize that. Elias Miller, what am I write next?
O2.
Plus O2 G. Alright. Makes arrow. What do you think for dinitrogen tetraoxide? Lily, talk to me. What's dinitrogen tetraoxide gonna be?
N2O4. When you do N2, there's no 2.
N2O4. There's 2 nitrogens, dinitrogen,
Oh yeah.
and 4 oxygens. Smiling on? What's wrong with this picture?
Everything.
No.
How
What's not
Part of
balanced?
it.
number of
No.
electrons?
Oh yeah, there's
Well, there's 4
The little
electrons on
numbers.
the right side, and there's only 2 on the left side.
Electrons?
Oh, no. I'm
The
talking
little
about
numbers.
The atoms.
What element is balanced?
and nitrogen.
What element is unbalanced?
Oh.
Oxygen. Okay, so what's wrong with this picture is the number of oxygens.
Oh.
We have 2 oxygens here, we have 4 oxygens here. That's our problem. So, how can we solve this?
You're gonna divide both sides by
What?
nitrogen.
I was
Divide both sides
actually.
by nitrogen. Interesting
Algebra.
idea to know.
You can't.
In some ways it is algebra.
You add more
I add more what?
oxygen
How many more oxygen?
2
Where?
to the other side.
Which side?
The left.
Which we call the what in chemical reaction?
The left.
Reactant. I need more oxygen on the reactant side. So, there's a temptation to just do this. That is not okay. Okay? Oxygen comes in diatomic pairs. So that's not allowed. Oops, you both get out of here. I'm not allowed to do that. Okay? Why am I not allowed to do that?
Because you said so.
Because we said it's tetroxide. It's not dioxide. So you can't go through and change those things. Instead, what we're going to do is we're going to double the number of oxygen packets I have by putting a this in front of it. What would you call that in math class?
Coefficient.
Who said 2?
Coefficient. Okay, here's the right answer
It
here.
was not me. by the
This
way.
is a coefficient. We are going to use coefficients to balance our equations. Coefficients we can change. The numbers down below are not coefficients. The numbers down below are subscripts. Okay? These numbers we cannot change. The subscripts we don't change. Those are what we worked on yesterday. Those are based on what the molecules are. Those are based on, well, NaCl is 1 Na and Cl. Sodium oxide is 2 sodiums, 1 oxygen. The subscripts we don't change in terms of balancing, those are dictated by the compounds. And that's what you practiced last night. The coefficients are what we're going to change to balance. Write those words down. Coefficients, we change those to balance. Subscripts, we do not change. Write that information down in your notebook, please.
Yeah.
Moving on. 5.
No.
I mean 7. 6. 5.
11. 3.
3.
0.7. 1. Go.
Great, dude. Just because I gotta go.
It's in my notes.
Alright, write down a chemical equation for this, and then balance. Go. Write down a chemical equation, describe this reaction, and then balance. Do you mind?
Oh, NH3.
Like, you know, it's just
Yeah, NH3.
Oh, because it's ammonia, not
hydrogen.
Hydrogen and nitrogen are both the what?
Ammonia.
Wait, so decomposes?
I did it.
Bam.
Hannah, what is the formula for ammonia?
NH3.
NH3. Okay? Decomposes into. Just draw an arrow. Something happens. It becomes something else. Hydrogen gas. H2. Nitrogen gas. Katie?
It's going to be an N2.
I mean N2.
Are you going to write the little G's?
I'm not. I'm not going to bother those subscript states of matter now because now this is the main event today is balancing. Alright? How many nitrogens do I have on my reactant side?
1.
How many do I have on my product side? 2. Is that balanced?
No.
Hydrogen. People who like to check their work, there's often a gender associated with that decision, will sometimes make tables like this in there, like next to the problems to test to see if they've got things associated with it. Okay? So, right now, my nitrogens are imbalanced. What am I going to do to get them balanced?
You're going to put 2 on the other side.
I'm going to put a 2 over here. Okay? That's saying I'm going to have 2 of these NH3 groups. That's going to give me the 2 nitrogens on my reactant side to meet the 2 nitrogens on my product side.
That doesn't change anything else?
It does change something else. How many hydrogens do I now have?
6.
6. So I'm going to make another row for hydrogen. Hydrogens, I now have 6 on my reactant side. How many do I have on my product side? 2. Is it balanced? What do I need to do to get it balanced? Put a 3 in front of each. Multiply the number of hydrogens by 3.
Why do you want this so bad?
Why? Because otherwise
Like what?
it's not balanced.
I don't
Okay?
understand Hannah's question.
Why do you want
Okay.
this?
Why do we need to do
Why do
this?
you want it so
Why do we have to know stuff about the world?
Just shut your mouth and just don't open it again.
Okay, so this is what we were trying to achieve, Hannah, is we know that this is true in nature.
Sorry, I just went off.
Okay, we know it's true in nature that if I put 6 hydrogens into a jar, after the reaction's over, there have to be 6 hydrogens still in that jar. And so I am trying to get an equation that accurately describes what happened in the jar. And so I'm trying to get it so this matches reality. law of conservation of matter, like whatever I put in has to be there.
Two ammonia.
So you could say those words, the 3 hydrogen gas and the nitrogen gas. We're not dealing with that. We're looking at Declan's phone right now. We're just trying to write down some equations.
Long text.
Well, I'll let you my life. Okay, questions on this? Okay. Game on.
Game on.
Okay.
Do you want us to balance it too?
First write it, check with your homie, and then balance.
So why do they even put that one there? It's plus.
Because if it's not 1, you assume that it's 2 metals. The default assumption for transition metals is +2.
Oh,
We put
yeah.
the +1 there to tell people like, hey, watch out.
Hey, everyone, watch out.
+1 charge. That one's +1 charge. And now
So
you
then
know
would
why.
I do AG1 and then I?
It's 2.
AG +1.
Sodium sulfide. That's a good question. I don't know.
Yes. So the
Alright.
But if you
AG plus 1
It's still an I. It's still the thing.
no, but it's not iodide gas. It's just
She's
iodide.
right. Xander, she's right. It's one by itself. It's by itself.
You're welcome, Hannah. I got you that back then.
Okay, and then sodium. What is the
My question is, what's the
I
thing?
always write
How do I find that?
silver as every single time.
Look at sodium, what its charge is. Look at sulfur, what its charge is. And procedure X.
Sodium sulfide.
sulfur is -2, and then there's 1 sodium. So that would be AG2. How inconvenient. Why would it be
It's a silver.
Wait a second. Oh, yeah.
Good job.
She's right. She's black grass. Do the demo or something.
Make silver for electrons.
You get tetanus.
You
You get stabbed by something
Rust.
Rust gets into your bloodstream.
You have to let 2I plus A2 that sheet makes it so where it's like
You
a shot. It was so difficult
All right.
to
I don't know.
Was that it?
Johnny,
Yes.
tell me your feelings about silver iodide. How do you feel about
It's gonna be silver plus.
it? Silver is +1.
Iodide is what, like -1?
So therefore, what's it going to be?
AgI.
It's just going to be AgI. Okay. So, Sophia, sodium gets what kind of charge based on its position on the periodic table? +1. The sooner you get comfortable with these, the faster this process is going to go. And the more you see these things, the quicker this is going to become. Sulfur, Lily. Elias, what's that thing's formula going to be?
Na2S.
Na2S. Okay. Make silver 1 sulfide. What Poland? Can you put those together for me in one step? Silver 1 sulfide is going to be
Ag2S.
Ag2S. The silver's +1, the sulfur's -2. That's how those are going to come together. Elise, sodium iodide.
The sodium Na.
NaI is correct. Okay, sodium's +1, sulfur's -1. We only have one Sophia in the room at a time. Okay. So once we've got this, now we're ready to do today's lesson. Okay, that was all like building things up. Now we're ready to balance this problem. Okay, Elise, how many silvers do I have on my reactant side?
You have 1.
1. Oh, sorry, not Elise. Cynthia, how many silvers do I have on my product side?
2.
2. So silver is currently imbalanced. How are we going to deal with that?
2 AGI.
I'm going to put a coefficient of 2 in front of the AGI. Okay, so now if I make my little table, reactant products, okay, this is 2 and 2. Iodines. How many iodines do I now have, Sophia Webster?
1 and 1.
Nope. Because I put the 2 here, that applies to this whole molecule. So I have.
2 iodines and 1 over there.
So what am I going to
2
do?
in front of the NA.
Walk over here, put a 2 in front of the Na. So now it's balanced. But that screws up my number of sodiums. Look, because now I have 2 sodiums on my product side. But definitely, how many sodiums do I have on my reactant side?
1,
Guess again.
2.
2. I have a subscript 2 on the Na. Alright, sodium is not S, sodium is Na. Okay? And then sulfur is 1 and 1, and so that's balanced. That's the internationally recognized symbol for I have balanced that chemical equation, by the way. So you make a punching noise using the punch to make the sound out there. 1, 2. And that's how you know that you balance the way. You see accountants doing that at conferences all over America. Okay, really international. All right, questions on this process. The balance is not the hard part. Making sure you have the right subscripts is a lot of what takes our time and energy on this. Go.
Oh, titanium.
Yeah.
What?
TI.
Like it's my job.
What is the?
Titanium is TI.
No, what's that?
Oh, it's
So
minus 5.
4. It's 1 less
Does
than
in
5.
water mean?
Do you have negative minus
Yeah,
4? But then what if your charge is? I'm just gonna assume.
Because it's always a charge on a metal. Metals get positive charges. You need to write the water here. Waters are part of the reaction. And you need to include the water. Because you see hydrogen and oxygen showing up on the product side.
So is
That comes from the water.
Is it plus H2O?
Yeah, plus H2O.
Hydrogen.
You got it already. You got it.
You already got that? Wow. So does that mean that we read as an aqueous solution?
No, this in
Or just
water
we're
is
putting
water
it
is
with
plus
H2O.
H2O. It is hard to know that. That is something you just get a sense of as you do it.
Bets. Did it.
Do the thing.
What's the whatever Hannah just said?
I didn't bounce it yet.
Aqueous,
Yeah.
that means dissolved in water. It's the little subscript EQ.
Minus 2. Ow! Why did I do that?
You gotta be tough.
Wait, what was
I
the what did they
punched
say?
myself right in the collar, bro.
Just the sound effect, it happens.
We're like gorillas.
But Dave, just in case, she's in the she's going to have 3.
I tried to look at my boobs.
Bad. Isn't that self-awareness?
It's good.
Where?
Wait. Whoa. Yeah, hold on. My kids are 40 yet. Delete those things are the tree. Oh. Okay. So, I have no idea where I am in the room. Let's start with Hannah over here. Hannah, titanium is plus 4. We've got that from there. Chlorine gets what kind of charge based on its position on the periodic table?
Minus 1.
Minus 1. So, Xander, what's the formula for titanium 4 chloride going to be?
TiCl4.
TiCl4. And I need 4 chlorines to balance up my titanium. Katie, what's the formula for water?
H2O.
Oh, yeah.
Oh
Uh,
no.
produces titanium 4 oxide. Titanium still plus 4. Oxygen's what kind of charge, Johnny? Minus 2. When I put those together, at least, what is that going to make? What is the formula for titanium 4 oxide going to be?
Ti2O.
I do not intend to have it be Ti2O4 because I can simplify that down to TiO2. Okay. Cynthia, hydrogen gets what kind of charge?
Huh?
Hydrogen gets what kind of charge? Positive 1. Sophia, chlorine gets what kind of charge? Positive negative 1. So Declan, what's the formula for hydrogen chloride going to be?
Hydrogen chloride.
Just HCl. Reading the words doesn't move the ball forward here. The idea that it's 1-to-1 HCl. Okay. So now we're ready to balance. So, Jamie, How many titaniums do I have over here?
1.
How many do I have over there?
1.
1. So titanium appears to be balanced. Awesome. Okay. Donnie, how many chlorines do I have here?
4.
How many do I have there?
1.
So what do I need to do?
Again, give him more.
There's more. How many more?
2.
3 more. How am I going to do that?
Balance.
By putting what number where?
3 to chlorine.
I'm going to say 3 chloride down here. I'm going to put a 4 in front of the whole molecule. And then formula this. I don't think about adding 3 more chlorines. I think of multiplying that one by 4. Like a coefficient of math, and multiplying that by 4. Okay? That gives me 4 hydrogens. So Sophia, what do I need to do on my reactant side? In front of the, not the hydrogen, I would say the whole molecule. In front of the H2O, or water. So we want to save that whole molecule, because that reminds us that the 2 is multiplied not just by the hydrogen, but also by the oxygen. That gives me 2 oxygen, which matches over here. Katie, question?
Are you allowed to like put numbers in between the molecules?
No. I'm not going to come through and change that there, because that's changing like how they're balanced to each other. I can only do it to the whole molecule or not.
So you can't put it on like the right side. Is that you?
Yeah, it has to be on the left side to the whole molecule.
Wow.
Let me tell you, most of you are getting the hang of balancing at this point, but some of you are going to get an SOL question wrong because this is how they're going to ask it. Ready? What is the sum of the coefficients in this balanced chemical equation?
Plastic.
That's so
It's gonna be.
What
I
is
don't
it?
6.
6 is what you look at. You look at this, you say, oh, the coefficients, if I add up the sum, add up all the coefficients, it looks like it's 2 plus 4 is 6.
8.
How many titanium chlorides are there? There is 1. There is a ghost coefficient of 1 on titanium chloride. How many titanium oxides are there? 1.
That's terrible. That's mean.
So if they say, what is the sum of the coefficients in the balanced chemical equations, in this case it is 8. You need to understand that anything that doesn't have a coefficient has a coefficient of 1. Anything that doesn't have a coefficient, it doesn't mean that there's 0 of that chemical there. There's 1 of that chemical there. Smile and nod?
No.
I will ask you that 5 times in your homework tonight to help you remember to do this. All right.